My name's Curry Searle. We've got Christian McHugh. We're doing a presentation on Jenkins for smarter operations. If that's not what you're here to see, we appreciate having you anyways. All right, so Jenkins for smarter operations. I guess it's smart to start with the question of what is operations? From the perspective, paraphrasing Wikipedia, it's a set of all processes and services that are both provisioned by an IT staff to their internal or external clients and used by themselves to run. It's responsible for the smooth functioning of the infrastructure, the operational environments that support application deployment, including the network infrastructure, server and device management, computer operations, IT infrastructure library, or ITIL for management, and help desk services for an organization. Thank you, Wikipedia.
So what makes that kind of important, for the reason why we're all talking to you today, is Jenkins is typically used for development practices and to assist with development workflows. And none of the stuff we just mentioned there really had anything to do necessarily with development.
So smarter operations, what exactly does that mean? Things like reliable, consistent, reproducible, automated, traceable, those are all things you think about. But reliable, service has to be up, otherwise it's not a service. Consistent, provide the same experience regardless of the instance. So you need to be able to grow it, destroy it, do it over again. Reproducible, allows for scalability and disaster recovery. Cloud-based services, multi-data center operations, depending on where your application or service lives, you need to be able to reproduce it wherever. And then automated. Service takes care of itself. All you do is monitor for health and growth. So all those things that we do, spinning up services, monitoring, all the different pieces of it, that needs to be automated. You don't want people in there pushing those buttons, or you can push the buttons, but all the technical tasks, you want to automate that as much as possible. And then finally, traceable. Sometimes you need to debug, audit, log, and verify. So the automated piece is where the service takes care of itself, but sometimes things go wrong, and you still have to know why, and that's where the traceability comes into play.
So what we're talking about effectively is taking an operations-based workflow, something that you don't normally think about as necessarily requiring Jenkins involvement. So we don't have developers writing code, so you don't necessarily have a Git repo that has to be pushed out to, say, a build process and distribute your build across multiple environments with a unit test suite against it to get the whole CI workflow. But in the operations stuff we were just talking about, there's still an awful lot of stuff to track and manage. And as DevOps and the tool sets that have been developed to support DevOps have gotten more pervasive, well, the operations folks have had to start dealing with those code-based workflows. And part of what the whole DevOps automation process requires is some amount of tracking and traceability to support all of your automation workflows. And so how do you get all that stuff kind of accomplished? So as the slide says, we're dealing with operations as code these days. That DevOps isn't necessarily just a developer, an operations team that works closely with the development team. It's, in my opinion, when you have operations staff that work based on a software lifecycle. So you keep your stuff versioned and codified, and you provision out your infrastructure from code, and so we need to be able to support that use case. So in the case of using Jenkins here, we have people running some stuff, and a pretty good way of facilitating that whole workflow is to give them effectively a Jenkins button to help them run that stuff. So when we first spoke to people about using Jenkins for a non-development-based workflow, we got some kind of strange feedback about, well, it just doesn't feel right, or it's kind of a hack, and it's not what it's for, right? Because like Jenkins has a build button, it's labeled build, and we're not building anything. And so there's other tools out there that have like run instead. And is that the only distinction? Is that the only thing that really matters here? What makes something a good tool for the process? One guy actually did support us, so thanks, Scott. So our requirements, what we're trying to actually accomplish with all of this. We wanted an interface to be able to script processes across all these machines and across all these environments. We wanted to have some sort of auditability and kind of trace about what was being run in these environments. We wanted to save the output of what was occurring. We wanted to be able to interface with source code revisioning, and we wanted to have some sort of API. And as you guys are at a Jenkins conference and we're talking about using Jenkins, you probably know what's coming next as far as Jenkins actually satisfies a good chunk of these things. So we can distribute builds across slaves if we have to. There are plugins to talk to Ansible or SaltStack or other things. There's some measure of built-in ability to keep track of your auditing of what's happening in your Jenkins environment. So and there's also plugins to send that off to something like Logstash for better archival. Likewise with the output logs, that's a thing that Jenkins just inherently does. Jenkins is fully capable of talking to source code revisioning systems, and it even has a pretty okay REST API to get some stuff done. This will come up later, but you potentially want to have some sort of interface with all of these services so that as your admins build up code, you might want to have, say, Jira or ServiceNow or something interoperate with the projects that have been built. And as we all know, Jenkins has a very active plugin ecosystem, which also makes it very attractive for these purposes. So if you want to do something with, say, Docker or AWS, there's plugins to help facilitate that. And there's always that one plugin that one guy wrote that one time that kind of runs everything and you can't deal without. And Jenkins is a really good place to find a bunch of those. So what are we actually talking about? We've now mentioned some vague requirements and this amorphous concept of using Jenkins. So let's get into some examples. With Dun & Bradstreet, for example, where I work currently, we have some pretty big data needs. We're running these pretty large Hadoop clusters, and we have a bunch of jobs that we need to run across these Hadoop clusters. We also have a lot of different independent teams that need to kind of work in these environments. And so there's effectively some maintenance that needs to be done, some job scheduling stuff that needs to be done. And since we have a fairly complex environment, there's a decent amount of training necessary to be able to operate in that environment properly. We also want to ensure that no one steps on each other's toes. And so rather than telling someone, here's how the environment works, here's 2 months of training to figure it all out, and a more improved way of handling that is generally you have a run book, right? And so you kind of schedule out what's going to, based on various scenarios, what steps need to happen. Well, even better than the run book is kind of automating that whole process so you don't really need a run book, and that's where the Jenkins stuff comes in. So if I have a job that I'm running regularly, I'm cleaning up some file system or something, or I'm running a compaction in HBase, then that's a regular thing that's happening in a kind of regularly scheduled way. So that's begging for some sort of interface like Jenkins where I can put that logic into the system itself. And so by putting that thing into Jenkins, I now have a place to run that job consistently. I can change where that job runs. I can provision it out however I need that job to run, if it's on Ansible or SaltStack or some sort of remote execution. When we say Jenkins, I mean the interface to be able to get this stuff run. And then once I have the job in Jenkins, I kind of get a bunch of those other things that we mentioned for free. So the logging and the traceability, who ran that job, what changed in our environment last night, what makes up the job? Did they run it properly? Well, yes, because they're hitting the go button in Jenkins. So it kind of sanitizes your infrastructure and makes it a bit more helpful. So out of all that, my goal is really to just replace runbooks with some sort of automation. So first, let's make sure all of our stuff's versioned. So we'll throw it all into Git, and we'll make Jenkins do something with those scripts that are in Git. That gives us, like I mentioned, the stuff for free of the activity logs and the consistent interfaces. And once we have all that stuff in there, I can now improve that logic a little bit. So I can add error handling to the job. And as things come up, we can improve our process slightly more rather than having to distribute and disseminate that knowledge to people with just through experience. And rather than having to version our runbooks and constantly update a bunch of instruction sets that we're requiring humans to read, we can just improve our scripts. And then finally, we can take all that stuff that we've put into Jenkins and delegate it. And that's kind of one of the key features that I wanted to talk about is not being a bottleneck. So these teams that have to get stuff done, they don't the sysadmins who are on these systems don't really care about the processes that are running. It's the development teams or the admin teams who are using those systems who care that the systems are running properly. And so if those distributed teams have some need to have something run in the environment, I don't really want them to fill out a ticket and then wait for someone to type in commands, or even in this case, hit a Jenkins button. It's much more beneficial if we can sanitize and have a safe operation and then delegate that Jenkins button to the team that needs to run it, and that's what makes this a kind of force multiplier of improvement.
So another piece of the puzzle where Jenkins comes into play for operations is in our identity management. We're often dealing with many non-open or siloed or task-specific systems. Sometimes there's not even an API at all. Sometimes it's a GUI that a person has to push a button and that sort of stuff. Jenkins is quite flexible in how you interact with it, so you have the things where you can use Selenium to write your web automation script that does that same thing that person does in the web GUI, but you can make a button out of that also. So at least the process is sanitized and consistent each time. You can send emails, provide a link, having to do with Active Directory, Office 365, or onboarding, offboarding. The ongoing management of those systems, a new person is hired, they fill out their ServiceNow or whatever ITSM tool ticket, goes through the chain of command, various points along that workflow, initiate Jenkins jobs to create an Active Directory group, add the people to various OUs or things like that. Also password expirations, any of the user management, account reaping when you're doing your offboarding or cleanup things. All sorts of, you name it. Again, with the extensive plugins and having your code written, created in Git, you can use PowerShell, you can use your shell scripts, you can use your whatever custom language, your interactive tool that you have to deal with supports. All that's capable. You can still wrap it inside a Jenkins button or a pipeline or various workflows. And so on that subject, the first thing you have to do is you got to define your outcome. What are you trying to accomplish? Define your authorizations. Who, if anyone, needs to authorize this? The things where you have your ITSM tools or your ServiceNows, that sort of stuff, those various pieces in the workflow, you can have those emails go off. Include a link to the ServiceNow ticket or whatever your OTRS. We've got some teams that use OTRS extensively. Collect your required information. It goes into your audit logs. All that stuff is documented, part of the request, how long it took. You can see where your bottlenecks are. Helps you fulfill your ITIL roles and requirements for auditing, be it a university like University of North Texas or health, hospitals, financial institutions. All that stuff can be encapsulated there.
So those added bullet points are what the various teams would use to try to figure out what was susceptible and made for a good automation story. So those are the bits that you had to answer up front in order to determine that this is a thing that they wanted to have Jenkinsified. And then once those were kind of answered, you're able to kind of get the process rolling.
Another piece of that puzzle was our enterprise applications team. They're kind of a fun story when they would have their weekly, monthly, quarterly maintenance tasks. Basically, the way that worked is all teams that were involved with the upgrade tasks for that quarter, annual, whatever, maintenance window, everybody showed up, all hands on deck, and they typically ran from, either 8 o'clock or midnight on Friday, finishing up sometime Sunday morning. All these people involved. Email chains going back and forth of, yes, this database is now down, is being patched. Okay, the application's confirmed it's patched. Bring this up, bring that down. All this done via email chains with dozens of people being involved in that whole process. So one of the cool things was we were able to replace, at least for a couple of the teams, they were doing these same tasks over and over again. You create some Jenkins buttons, if you will, automate those processes, and you hand off that process to your operations desk, who people, they're staffing the phones already 24/7. You let them push the button when their line comes up in the discussion, when they say, okay, it's time to bring down the database. Push the button to down the database. And instead of having the entire team on staff or on call to, verify those pieces, you have one person from each team just in case. You have your monitoring checking in that says, oh yes, that database is now offline. It's okay to down the application. Okay, this application's offline. At each one of those gateways or those gates, you push the next button after your check is done. So in one case, you get to the point where you only need one person on the team on call just in case. In the event that something doesn't go right, operation has to pick up the phone, they know that person's on call, and they take care of it, instead of the entire team or group of teams. And so, going back to what Christian said, don't necessarily aim for run books. Hand off the proper automation in a Jenkins button. If it's something that a part-time student employee or a help desk person that answers the phone that doesn't have to have the technical expertise, hand that job off to them once you've proven that you know what the task is and that you've automated it, scripted it. And then let Jenkins take care of the rest. Fourth example, we got here monitoring. In our monitoring environment, we have a Zabbix cluster, different nodes and different data centers doing various pieces of monitoring. That monitors the entire enterprise. One of the problems you run into is the need to monitor devices that you can't get a shell on, or a black box, or some device that the security team has purchased and put in line and that sort of stuff. So there's restrictions on who can have access to that and who can run code against it, or various things like that. So one of the things you can do is, the way we've implemented Jenkins in this case is we give the security team a Git repository and we let them put their custom scripts in it. Only they can have visibility into it, along with the Jenkins account that runs the script on one of the Jenkins proxies. So you can specify where it runs from, who runs it, who has visibility into the code, and then Jenkins runs the script, collects the information, feeds it back into your monitoring system for your metrics. Another area in the maintenance or the monitoring realm is just ongoing maintenance. It's like any other application your monitoring tool is. Database, logs, it needs to run tasks. Occasionally we'll have hiccups in that. Something will say that it's down or it's not, or there's a line needs to be fixed in the database. It's just like any other system administration bits. You do your investigation as to why the thing's happening, why is it breaking. You write your script to automate the fix, and then you put that in Git, build a Jenkins button, so when somebody calls up and says, oh, that thing's down, or that thing says it's down, but we've done through all the checks that it's not, you push the Jenkins button to fix your routine maintenance. Another example where we're using Jenkins in for automation in this way is Dell CFI and SCCM. So you take situations where if you're a Dell customer, you have the option to have them build an image in their factory based on your requirements. They run it through smoke tests, make sure everything's good. They put it on the machine, box it up, ship it to your customer. When the machine comes and is unboxed, it's fully functional. Well, as you can imagine, in an area, our university, we have 20 or 30 different IT shops that are all handling desktop computers and that sort of thing. So everybody has a little bit different way of doing it. the English department is different from the physics department, and different IT shops handling those. So this Dell CFI thing, where Jenkins helps us out, is the Dell process. When a machine is purchased, an email is sent that has MAC address, service tag, purchase order number, various pieces of information about that requisition. It comes in to an email server, is parsed out into it's an XML file. It's broken out with the various pieces of useful information. Jenkins takes that over, or the script hands it off, the various components, to Jenkins jobs that do things like, hey, this goes in the English department's subnet in their building, registered on the network in there. Pre-create the workstation object in the English OU. It needs to have this particular set of software installed. So when you create the workstation object in SCCM, pre-populate those as part of the task sequence. Printers, all that sort of stuff. And then you get the benefit of when the machine arrives, instead of it coming into the queue and the next tech that has to go out, spend time doing that, that's all eliminated. You have your person. It could be an office staff member. If it's a power user, they know how to unbox a machine and plug in 4 cables and turn it on. Let them do that. SCCM takes over, fully functional 30 minutes later. That machine's ready to use. That includes things like drive encryption. We specifically use that on laptops because those things come to conferences and whatnot. And so Jenkins can facilitate taking care of that process through reboots, through waiting for drive encryption to happen and that sort of stuff, through another set of, hey, did this process kick off? Cool. Register a flag in the Jenkins artifact, or the various pieces of this is where it is next in the pipeline. You're using some of these coding concepts, moving coding bits around, but we're not coding. We're just installing software on a computer, but you can use some of the same facilities in the same way.
Effectively, at that point, Jenkins, we're just treating it like a workflow server, right? But it turns out that Jenkins isn't a terrible workflow server, and a lot of workflow servers are really terrible workflow servers. So in this case, because it talks to the Git repos and has all the notification plugins and the active plugin ecosystem to be able to reach out and touch stuff, it does this job really, really well. So even though the button is labeled build, it's still very much worth looking at. All right, so it's Central Web Services at the University of North Texas. They run about 1,000 websites or so. Those websites are all managed by individuals at various different departments. And so when you want to do something like add a user to a website, well, that probably invokes like Active Directory as well as Drupal and some custom htaccess stuff and a bunch of things. And so again, we can train our admins, which means whenever we get like a new person on the team that has a large ramp up time to make them useful, and we have to have like this ever increasing larger team to be able to handle the workload that's coming across, or again, we can throw those jobs into Jenkins. So great, we now have some stuff in Jenkins. As we mentioned, we can track it and figure out what's going on, so that's working pretty well. We can have add in like the workflowy bits so that maybe a request comes in from a ticket and that kicks off Jenkins to do a thing, and then Jenkins does some stuff and then it updates the ticket. And so that works out pretty well. And then again, you can delegate that button out to people. But when we're talking about end users, you don't want to delegate a kind of ugly looking computery Jenkins button thing to anyone, because that's not something that like an end user really appreciates or understands or cares about. And so the next and final kind of evolution of this whole process is to build some kind of wrapper around it. When you come up with a service catalog for a large institution, you probably have just a suite of things that you're allowed to run. Request a phone, add a user, whatever that thing is. And so those front ends are usually oftentimes like a cloud-hosted service like ServiceNow or even Jira or whatever, in which case those scripts that you're running and all those jobs you're doing still need to be run somewhere. So great, you have the button up in ServiceNow in the cloud somewhere, but how do you get that code running on, say, Active Directory in your environment? Because you probably don't want to have ports open for Active Directory to ServiceNow and your database server and your file servers, and you have all these independent hooks. So again, Jenkins to the rescue in that you have the Jenkins job, and so you have your ServiceNow or whatever interface in the cloud that can now call the REST API of Jenkins to do something useful. So in this case, we built a web front end. So at the University of North Texas, we developed a user-facing portal where user logs in, because of whatever Active Directory groups they're in, they're able to see their websites that they're associated with, and they get a screen that looks something like that. So great, we have a screen. Part of that screen, though, involves some buttons that an end user might care about. So in this case, adding or removing accounts or clearing the cache on a website, let's say. So if you were to hit any of those buttons, you'd be brought to a screen kind of like this, which effectively is a parameterized job in Jenkins. I've got some user input here, and I hit go. So people thought the cool looking little web form, because Bootstrap's awesome, and then they're back to their main screen where they can see, hey, I've got some jobs running, and if you open that up, it shows you all the active running jobs. So this website is what is being used for end user access at the moment, and it is effectively a prettier front end to Jenkins, where it's talking to the Jenkins REST API, and there's a plugin to have Jenkins notify a web endpoint on the completion of jobs. And so those couple of things together complete the whole circle. So we had a job that needed to be run, we threw that code into Git, threw it into Jenkins, and we had the team that did that thing hit the button. Well, we can delegate that button out to other technical teams, but then the final evolution is you build some cool front-end thing and have it wrapped into your service management's catalog, and so Jenkins now is responsible for that entire pipeline through the entire life cycle of what makes that thing that thing. So everything's not totally awesome, because Jenkins actually isn't built for this. Shoot, cool. So the question's around how do you manage this crazy infrastructure? So great, we set up that Jenkins server that one time. You might have multiple Jenkins servers. Something's going to go wrong. A server goes down, and now you have that exposed to your end users. So how do you manage all of this nonsense? Through a whole lot of configuration management and a whole lot of monitoring. So in this case, it's backed by a single Jenkins instance. That Jenkins instance, however, was provisioned entirely through some configuration management tool, and some of the interfaces that Jenkins is using to reach on touch the rest of the infrastructure are all done through other APIs as well. So effectively, if a job doesn't fail, it doesn't fail all the way, so that we have an atomic ability to run any of these individual jobs, because it either calls the API or it doesn't, often. So in the case of the Jenkins server goes wonky, cool. I mean, in this day and age, I'm not dealing with hardware very often, so kill the VM, like have your monitoring server notice that thing's not acting properly through whatever metrics you decide defines proper, kill off that VM, provision a new one, and off you go again. So if you have a known stateless version of the API gateway, it's not the end of the world to be able to restore it, because there's nothing on that Jenkins instance that I actually even care about. All of the code itself lives in Git. The services live elsewhere. So the Jenkins server going down means that that button doesn't work for a couple of minutes, and the user would be notified in that it doesn't trigger any action on the website's part. Yeah. I forget off the top of my head, because it's been a while since I've looked at it. So the question was, what was the plugin to respond to the web front end? Find me afterwards, and we'll Google it real fast, because I forget off the top of my head. This comes back to that one plugin that one guy wrote that one time. It's everywhere.
Also, to touch on your point about the configuration management and whatnot, we actually have some groups within our organization who run whatever their configuration management tool is, in our case, SaltStack. And they have a Jenkins node that's a salt master, or has capabilities to issue salt commands. So you can also do some of that provisioning or cleanup, or what he was talking about, spin up a new instance, destroy an instance, that sort of stuff, kind of through a clever chain of events, again with the Jenkins button.
There's also a Salt plugin to be able to talk to the Salt API, so the choices are endless because it's computers. So not all perfect, that there were some pain points. These pain points got really anticlimactic, though, over the past year. So job creation, backup storage, all that stuff kind of sucks. It's not the greatest, but it's a whole lot better with pipeline and if you use job DSL or some just raw Groovy. So managing all of these jobs independently, if you're clicking around the interface, it becomes kind of overwhelming. So going back to the whole configuration as code thing, historically we might use the job DSL to handle the actual job creation and all of these scripting processes or whatever that make up that job, all of the calls out to external plugins. So make sure you're not just clicking around the interface, because that gets you away from the stateless machine that is necessary to make all this stuff function at scale. The UI isn't awesome as far as tracking existing pipeline stuff. So through some of these workflows, because it's a weird workflow server and not just a pretty linear build server, you might have a job that has some logic in it to call one of, alternatively, one job or another. And so you kind of have these fragmented pipelines. And the visualization for that isn't great, so it's a little weird to just at a glance see what Jenkins is doing at the moment. But that's actually getting kind of resolved with the work in progress that is Blue Ocean. So it's handling some of those visualizations a little bit better. The plugin dependency problems in Jenkins are getting a little bit resolved with all of the Groovy script stuff. So setting up a Jenkins server for the very first time, going back to how you provision out a Jenkins server the first time from code, invoke a bunch of Groovy. That's going to save you some time. All right, so out of all this, Curry and I are talking to you today, but a lot of the stuff we're talking about was lots of different people and lots of different teams at a bunch of different organizations. So thanks to all of them. And with that, are there any more questions? So the question was, web portal, is that open source? So I have thought about it, and I've encouraged the folks that wrote it to do so. So I'm just waiting on them to hit the upload button. That everyone's kind of agreed, so it's just a matter of time. So watch that space if anyone has any interest in a web front end to things. It's kind of simple PHP, so it's pretty malleable to whatever environment you want to run it in. Can you test Jenkins's REST interface, or can Jenkins test a separate REST interface? So whatever you want to script, it will do. So the question revolves around REST interfaces. Can Jenkins call it to other stuff? So sure, but oftentimes the way we ran all that stuff, you end up with a Jenkins server that has a bunch of plugins on it. And those plugins work the way that they're working. You kind of don't touch it. It's a house of cards to some degree. So you often have a development instance or a testing instance of Jenkins also for any of those purposes. Because we have multiple instances of Jenkins already, then we might have different jobs that we have on those individual Jenkins instances. So something like testing REST interfaces, I wouldn't put on the main production interface because I don't really want to have, just junk it up with 100 jobs. But I might throw that onto a different Jenkins master. So questions around automating all this stuff costs money. So at what points do you say that it's not worth it? At what point is it good enough? So it's precisely, I think, for me, that good enough threshold, where if the team themselves is feeling pain, you need to fix that. The ultimate goal of automation is to run the service properly. So if you're not staffed with enough people that it's currently awful to run that service, then you need to run the service better, or change how you're running that service, or mix something up, because that's not a long-term maintainable solution. So the end goal of any of these efforts should really be trying to drive the maintenance costs down to zero while still providing the thing you need to do. So as folks had time, they would tackle small parts of this. So building up that little script helps you, it's a big win immediately. Throwing that into Jenkins is a big win immediately. Developing a web front end to Jenkins because you want to delegate that out to your customers, you don't necessarily have to go that far. It depends on how many customer requests you're getting. So I have a real amorphous answer of keep doing it until you don't need to anymore.
On that exact topic of the time, another thing that we ran into was back on the subject of workstation management and SCCM, Microsoft System Center Configuration Manager. One of the cool things that we're doing with Jenkins as part of the workflows is application packages that everybody uses that are updated constantly. Can you think of some of those? Browsers, browser plugins, that sort of stuff. We've actually gotten to the point where we have a set of scripts that go out and watch the repositories. I say repositories lightly, but the download locations for Flash, Chrome, Firefox, both the extended release and the regular to build cycles, all these sorts of things, recognizes that there's a new binary out there, downloads it, checks, MD5s it, makes sure it's a legitimate file, extracts it, builds a templated SCCM package, spins up a VM, assigns that to a testing task sequence, deploys that piece of software to that test workstation, and then runs through some tests. We can do that for, of course, Windows 8, 8.1, Windows 10, that sort of stuff. And then you have your test sequence, the same way you would on your job, moving code around. You can do the exact same sort of stuff, and those are some other pieces that we have in production. Not all of that top to bottom, but we're very close to having that as a solved problem as well. So in our particular case, we just recently moved to ServiceNow, so we don't have all of our automation workflows in place for ServiceNow. In some of our areas that are still using like OTRS, that have been established there for a while, specifically our central web services, the things that we demoed that help desk, it just takes time. But yes, those things are done. It is capable. We're just not up to speed on the ServiceNow specific instance of that. ServiceNow is the platform we've gone with for our ITSM tool, yes.
So because Jenkins has the plugin ecosystem to do development these kind of tasks, things like spinning up a VM to test out the SCCM builds, that's real similar to development workflows, but doesn't actually involve development. So if you can get output of anything, in this case Ansible, make sure it's output in the computer-y format, because your build job might not just be run this Ansible thing. You can kind of wrap that in something larger. So your build job might actually just be a more horrible shell script version of that, where you do the Ansible thing, save its output, parse that properly, and let that determine your build status in Jenkins. And then at that point, you're able to add the logic to say what determines a build failure. Is this good enough? The other kind of only option you have is to break that up into bite-sized chunks as much as possible, so that you're not as reliant on 1 out of 300 machines being down, failing the whole build. So if any ability you have to batch that up into smaller chunks saves you a little bit of pain there as well. Like Curry mentioned earlier, the configuration management tool that they were using at the University of North Texas is SaltStack, so that also does remote execution-y stuff. And there we had a couple different models where we used both a plugin in Jenkins as well as just having the Salt master run Jenkins itself, so that the builds themselves were showing out to running Salt. So effectively, if you do that with Ansible, it's kind of the same thing. If it doesn't fit your needs, totally. I mean, so I wrote the SaltStack plugin for Jenkins for that reason, because nothing else did it enough. I had to have enough logic in there to be able to disseminate those individual steps. Well, thanks everybody for your time, and enjoy Jenkins World.
Thank you.